Okay, let me share my screen so we can look at the cone problem. Okay, here we go. You ready? I'm gonna fill it up. This is a really cool problem. You guys will like this. Water is flowing into a cone. It is not the incredible growing cone. The height of the cone is 16 centimeters. The radius of the cone is 4 centimeters. That's not changing. What is changing is the radius and the height of the water in the cone. Does that make sense? Cone, same size. Water, different size. Water's changing, all right? The water is flowing in at this rate. You get a huge clue right here. It's centimeters cubed per minute. That's a volume rate. All right, squared is area, cubed is volume. That's a rate of change for the volume of the water, volume of a cone. They don't give the volume of a cone here, but that would be provided to you. I would give you that, okay? How fast, that's your question mark, is the water level rising? So that's H, dH dt is what we're gonna be looking for. When, we're gonna pause, when the water is 5 feet deep. And what I think about is really cool about this, watch. It fills up really fast at the beginning and then the volume slows down. Do you see that? No. Why? Because it goes, because there's less space. The radius is smaller at the bottom. So that's interesting. All right, I'm gonna stop sharing. Now you can draw a whole cone if you want, but essentially what we need are the right triangles out of that. So since I am not a fantastic artist, I'm just gonna draw the right triangles. All right, so the radius of the cone was 4 centimeters and the height was 16 centimeters. I put those on there as values because they aren't changing. That's staying the same. What you need a variable for is the height of the water and the radius of the water. This is the water in the cone, okay? Pretend that that's like colored blue. Now they gave us the rate at which the water was flowing in. That's dV dt, the rate of change for the volume. It was 2 cubic centimeters per minute. And again, that cubed is your hint that that's a rate for volume. We're asked, what is the rate of change of the depth of the water? And they called it depth, but that's H for height. So what's our question mark value? Good, dH dt, should it be positive or negative? Positive, because it's filling up with water. And then we have to pause. So it said at the moment when the height is 5 centimeters. We're gonna pause at that moment. The relationship between the variables is the volume of the cone. Again, this would be provided to you. Volume of a cone. Does anyone actually know it? Oh, there is a 1/3, good. Do you remember your area? You guys told me the area of a circle just a minute ago. Well, it's pi r squared h. 1/3 pi r squared h. So it's the circle, that's the pi r squared times the height. That would be a cylinder. And then 1/3 of it makes it a cone. Did you follow me there? A circle, hold on. So the circle of the top, imagine like a Coke can, that's pi r squared times the height. That would be the volume of a cylinder. But when you split it into thirds, that makes a cone. Oh, there we had like an aha moment there. Okay, cool. So anyway, that's why it's 1/3 pi r squared h. I'm going to give that to you. That would be given to you. You don't have to memorize that. But now you might remember it because I showed it to you. Anyway. All right. Now, I know I said the first thing you need to do is the derivative, but we do have a little bit of algebra to do here first because we have a problem. We have information about height. We have height is 5. We're looking for dH dt. We do not have information about r. We need to get rid of r. R is a problem. Get it out. We need to substitute r out of here. This is a lot of algebra. It is not calculus. It is just algebra. I need a relationship between these, and we're going to set up a ratio. When I taught geometry a million years ago, I called it the mommy triangle and the baby triangle. All right, we're going to do a relationship between those, a ratio. 16 compares to h. And then what can I put on the other side? 16 compares to h 4 to r. Do you guys follow me there? And then we're going to cross multiply. So you'd have 16r equals 4h. And you would divide over the 16. So what does r equal? 1/4 h. Good. We recap. Did everyone follow me there? Because it's not hard. You just have to write it down. 16 compares to h, 4 compares to r. It's mommy triangle to baby triangle. We cross multiplied. All right. You're going to take that 1/4 h, plug it in for r, and then simplify it down. Again, it's not calculus. It's just a bunch of algebra. So you're going to take out that r, and in its place, you're going to put 1/4 h. Give it a hug, which means put parentheses around it. That's what I call that. Give it a hug. And then to simplify it down, this is kind of like PEMDAS. What would you do first? Parentheses, and we're going to square what's in there. Perfect. Parentheses and exponent. So if you square what's in those parentheses, that would be 1/16 h squared. And then we're just going to multiply. Next would be multiplying these together. 1/3 times 1/16 would be 1/48 pi, and then it would be h to what power? 3rd. Good. Why 3? That's correct. Perfect. Okay. All of this that we just did is algebra. Okay. And you can't let that part scare you, because I guarantee that that's the part that scared you last year. I guarantee it wasn't the calculus, because I'm about to do the calculus and it's one step. All right. You have to set up a ratio, substitute, and simplify it down. All that's algebra. Now we're going to do the calculus. dv dt. So you're going to bring the 3 down. It would be 3/48. You can leave it as 3/48, but that would reduce to 1/16. So I'm just going to reduce it. Pi h squared. That was your power rule. The pi throws everybody off, but it was just a power rule. We brought the 3 down. I reduced the fraction. Pi h squared dh dt. And now we're going to plug in. And we have everything. There's not going to be like a side problem. We have to go back and find something. What was dv dt? 2 equals 1/16 pi, what was h? 5 squared dh dt. And I'm going to be real honest with you. When I get to this part of the problem, I'm like, I have already worked hard on this problem. If I want to get dh dt by itself, all of this just gets divided over. I get to the point where I'm over it. Do you know what I'm saying? And I would just do that. You're welcome to simplify it down, but if you mess it up, it's going to be wrong. So that's my 2 cents on that. All right, units. It's not going to be centimeters cubed per minute. The reason that was cubed is because that was for a volume rate. We found the rate of change of just the height. So it'll just be centimeters per minute. Cubed is for volume. This was just height. Less scared? Or we still hate it? Less scared. Okay, I'll take it. A lot of algebra. That's why we like the table problems. You know the table problems? Because those are pure calculus with no algebra. It's just a bunch of numbers. What'd you say? Oh, really? Oh, I like them. Oh, this is like really glitching. He should be walking a bit quicker than that. Anyway, this is about the guy walking away from the lamppost. It is not the incredible growing lamppost. We're not in Narnia. That's 15 feet. He isn't growing or shrinking. Someone always wants to be like, he could be shrinking. No, he's 6 feet. Okay. He's walking away. He walks at 5 feet per second. And there's 2 questions. This is going to be a part A and a part B. First, how fast is the shadow lengthening? And secondly, how fast is the tip of the shadow? That's this little red dot. How quickly is that moving? Have you guys got it? Because again, I can't show this and the paper at the same time, but why is it like he's moving really slowly? Maybe it's because I'm doing it through Zoom. Well, no, but he usually moves faster than that. Yeah. It's probably because I'm sharing the screen through Zoom. All right, so here are our right triangles. The lamppost was 15, was it feet or meters? I have it written down. Feet, 15 feet, and the man is 6 feet. You can label those because they're not changing. Now he is moving though. He is walking this way. And this distance right here between him and the lamppost, that's what I'm gonna call X. You can call it whatever variable you want. I just usually go for X and Y because it's easiest. He is walking, what did they say, 5 feet per second? I wrote it down so I could look at it. He is walking at 5 feet per second. And part A, or I'll call part A here, was how quickly is his shadow lengthening? So his shadow is from right here to right here. This is his shadow. Let's call that Y. And so Y dt is our question mark. They kind of told you that it should be positive because they said shadow lengthening. So that is going to be positive. You cannot do Pythagorean theorem. Why not? Yeah, and you don't have any information about it to begin with. That would be like from the lamp, but like if you were walking, that would be like up there to down there. Like how would you even have that? So we can't do that. Instead, it's going to be like what we did with this one. It's going to be a ratio, the mommy triangle and the baby triangle. All right. 15 compares to 6. Good. And then on the other side, the big triangle would be X. There we go. Yeah, you got to add them together. X plus Y. And then just the smaller triangle would be just Y. So it's the big triangle compares to the small triangle, and we're going to cross multiply. Actually, can we reduce this fraction first? That'll make the numbers smaller. What's that going to reduce to? Yeah, 5 2s, 5 seconds, 5 halves. Just to make the numbers smaller. That's the only reason. All right, so cross multiply. You'll have 5y equals 2x plus 2y. And then we want to get the y's all together. So I'm going to subtract this over. So we'll have 3y equals 2x. And then this is just about the easiest derivative you're going to do. It would be 3 dy dt equals 2 dx dt. There's like almost nothing to that. And then you just plug in. Dx dt is 5. So divide over the 3, you get 10/3 feet per second. All right, part B for this, and then I'll give you a break before we do the last one. Part B was how quickly is the tip of the shadow moving? And they labeled that with like a red dot all the way out there. Now that's the distance from the lamppost all the way out to that dot. So I'm gonna call that entire distance Z. You can call it whatever letter of the alphabet you want, but we've used X and Y, so I'm gonna call it Z. Hey, Miss Cole, can't we just call it X plus Y? Well, no, because what we're talking about is that quantity in its entirety, and you can't do an X plus Y, dx plus Y. Do you get what I'm saying? Like it won't work. You have to have a whole quantity for that. So dz dt is what we're looking for. It should also be positive because he's walking away from the light. So we're going to set up the ratio again. You're pretty much going to do exactly what you just did again. 15 compares to 6, which I'm actually just going to write that as 5 halves. Big triangle to little triangle. And then now the big triangle, we called it Z. And then the little triangle is what? Y. Perfect. And then cross multiply. So you get 5y equals 2z. It's about the easiest derivative you're going to do. 5 dy dt equals 2 dz dt. Now you have to have done part A to get to part B. What did we say dy dt was? Yeah, 10/3. And so all you have to do is divide over that 2. And again, once I get to the end of a problem like this, I'm so over it that I just leave it like that. If you want to simplify it down, you can. I recommend against it. And then units are feet per second. All right, I have one more we're going to do. We'll do a little break first, though.